Doing another stream, so this will be on the recording. Meantime, just gonna publish. Testing the chat. So let's see if this works. So I've got I think I'm watching it that way. We'll see. Telescope's up. Everything was aligned as of yesterday, as of last night. Everything seems to be working. So right now I have just this set up, and let's see. So let's do a quickie overview of what I've got. Let's see. Yeah, we'll just go ahead and do this now. So we're going to do a quick overview of the equipment that I have. There we go. So right now I have 2 telescopes set up. Here is the equipment. So this is a Celestron CGEM DX. This is an equatorial mount. It's lined up with the North Celestial Pole. Basically it's a point that's very close to Polaris. And I have a Astrotech 6-inch Ritchie Cretin. This is an astrograph. This is basically a dedicated photographic scope. It's not really meant for visual. And I've got some issues I've got to resolve. And over here, this telescope, this is a Teleview 101 refractor. This is an apochromatic, means there's very, very little color. This is going to be similar to the type of telescopes that you may find at Walmart, but this is, quality-wise, this is a whole lot better. So everything's aligned, everything's set the way it should be, and now we're going to try to connect it. So open it up. Hey Doc, how you doing? Ewan's watching.
Hello, Dr. Ewan.
Okay, let's push it that direction. That's a little better. Okay, so right now it's not set up on anything in particular, but we're going to go ahead and connect it. The way I can do that is connect telescope controls. Let's find out what's going on. I thought I had everything connected. Guess I do not. Alright, we may have to do something else here. Thanks, Doc. Okay. So, what I'm going to have to do is reconnect something. Alright, so what I just did now is hopefully fix the connections. Because if this doesn't work, I'm going to be a little bit annoyed. Let's see, configure this again. Hey Rod, I guess you're on here too. So, if you want to chat, the Yahoo chat is available too. So, COM port. I don't see a COM port. Nuts. Alright. Let's do this. I'm going to have to get some cameras connected. So let's go ahead and do that now. In the meantime, here's what I want to take a look at. Dr. Ewan wanted to know where Uranus is, because he has a sense of humor. So actually, if you want to play that game...
He's a doctor, he should know where your anus is.
Yes, what's that line? Play stupid games, win stupid prizes? So I don't think we can actually see Uranus right now. I think it is actually below the horizon. And if we're going to reuse the old Futurama joke, then scientists rename Uranus in 2159 to end that stupid joke once and for all. The new name is Erectum. So I'm going to go ahead and center that. So we're going to be looking at Saturn. It won't be quite this nice, but we should be able to see the Cassini division out here, which should be quite nice. And we'll definitely get the separation. And last time we were looking, we could actually see the shadow on the back from Saturn onto the rings. So it was quite nice. But now I've got to figure out why my connections are not working. Oh dear, oh dear, oh dear. So because if this doesn't work, nothing's going to work. And I don't know if I'll have the cameras running. If not, this is going to be a really short presentation. Let's see if I can see it. Configure properties. Nothing. I have no COM ports. Well, that sucks. I'm not sure. What I was going to do is try to get an image of the lagoon and the Trifid, but something isn't working. There we go. Yeah, internet connection's kind of wonky right now, so alright, here's what I'm going to do. I've got to figure out why this connection's not working, so I'll flip the camera over to here. Look at the telescope. So what I should be seeing is everything's aligned. Let's see. Actually, it's not bad of a position. I just need to see what I'm doing. So I am connected, apparently, but something's not quite right. So I'm going to change the cable out, thinking it might be the cable. So I'm actually using a USB 3 hub directly on the mount itself. So if you look right here where I'm shining the light, you can see that blue light there. The blue light is a USB hub. I have it mounted directly on the scope for ease of access and ease of use. And right now what I should be doing, I actually want to see if I can do this directly. I don't know how well this is going to work. Can always try. Okay, so this is connected. I want to see how well it connects back to the laptop. I know, it's mostly dark. Let's see if we can see something. Alright. Shark cap, remind me later. That's fine. I want properties. Should be no. Still not connected. So I am missing something. What am I missing? I have a camera. I have USB ports. I see nothing else. So I've got a second monitor on here that I'm checking my settings on, and I had this working just fine yesterday. Absolutely fine yesterday. So what is wrong with this thing today? Well, I don't know. I honestly don't know. I'm going to try one more trick and see if this does it. Bad. So I've reconnected. I now have COM ports. Okay, I think I have a bad... Yeah, I think that may be it. I think I may have just a bad port. I'll double check it with the mouse. just dropped my connection again. And yeah.
To jest strasznie internet. Nie wiem, w tym
Yeah.
rejonie.
Apparently it's not. Okay.
Tak świnko.
I think I'm still live. Prepare to be live. So let's bring up something. Let's do configuration, check the telescope drivers again, properties. Now I got COM port 6. That's all I want to see. And now we can connect. And there we go. Telescope is tracking. Cool. We have sub-telescope control. Now I'm going to zoom out, figure out where we are. What are we looking at? There we go. Telescope is somewhere up there near Denab. Okay, let's swing it on to Jupiter. See what we can see with Jupiter. Let's see what it does. Let's see how this telescope does it. Actually, it's doing it halfway decently. I'm actually impressed. I think. Maybe not. Maybe it's doing it a stupid way. It's doing it a stupid way. Why does it do it the stupid way? Alright, fine. It's doing it the stupid way. Let's fix it and do it the smart way. I'm gonna let this thing keep going. Now we're gonna watch it on here. Let's see how close we can get it. Oh, it's so close. Okay, cool. Let's see what this looks like. Let's see how close we are. That's pretty decently close, but not quite as close as I want. So, I'm going to do this. Wrong direction. We're going to center it. Cool. So now it's close to Jupiter, though not quite. It's still not bad. Okay. Now I'm going to go ahead and give it a camera, and we'll connect it, and then we'll test it again. So I'll leave it on here, and we'll just get some work done. pretty good. Should probably have a light that shines on it normally. So now that it's on there, let's take a look at what we got. I want sharp cap. Let's kill sharp cap, remove. Okay. This, drop that down. We don't need that right now. We're gonna do this. Let's find the camera. We got a camera. Zoom. Let's check out 50%. What am I looking at? I don't have a clue what we're looking at. So I've got nothing. I've got nothing. Mono, that's fine. Yeah. What I want to do is see anything on here. And I don't see anything. Wrong direction. I don't know exactly how close we are. Probably not very. How's that? Not very. So, okay. How are we gonna do this? How are we gonna do this? Okay, I have an idea. I need to make sure I've got Jupiter centered first. So I'm going to go there with some eyepieces and test that out, make sure just how close we are, and then do a resync. Grab the paddle and recenter. Oh, here we go. Cool. Now we're close. Alright. Yeah, it's not bad. So there's Jupiter. And we're going to do some focal changes. So right now this is well out of focus, which is fine, at least for now. We're going to fix that. The way we fix it is focus. Really? Really? Alright. I need an extension tube. It's not my tube. had another tube. I had a second tube. Where did my other tube go? Let's go find a tube. I have no other tube. I found my other tube. So with a camera. So pull that off. Cover that up. Now I have a tube. Also on this tube is, I don't know if you can see that very well, this is a filter. It's got a little bit of dust on it, but that's okay. This filter hopefully will cut out some of the light pollution that we're dealing with. Down. We'll try this again. There we go. There's a Jupiter. See, it's a little bit out of collimation, so it isn't aligned as nicely as I had hoped, but we're getting it down there. Right. So this is a very, very bright Jupiter. Ooh, we can see moons around Jupiter. Let's get those in focus. That's what we really need to see. I'm going to have to keep walking back and making sure these settle down to little bitty points. A little bit more. Still a little ways back. Gotta find focus. It's hard to tell. That's back in the other direction. Okay. That's pretty annoying, isn't it, though? I'm going to turn the laptop a bit so I can see it from this side. Kojamos mnie pomóc? You know what? Never mind. I'll do it this way. Sorry. Okay, we're going to go 200%. This is the right way to do it. There we go. Now we can see the moons and see just how out of focus they are. They're like little bitty comets or something. So I just need to focus it down. That's actually getting worse. That's not that great, is it? I'm not actually able to get those down. That's not good. If I knock this down quite a bit. So here's the exposure, so I'm going to bring it way down. I want to bring up the moons. Maybe I do need 2 seconds, 1.3 seconds. Alright, let's see if we can just get that in focus. I think I'll be able to. Don't think we'll be able to. Let's see what Jupiter looks like. I'm going to take the exposure and bring it way down, see how much. Yeah, Jupiter's way out of focus. I think the major issue is that this telescope is just seriously out of alignment. I'm not going to be able to do much with it. Trying to get this into focus, and it's just not going. So we're kind of out of luck. The reason why I think I'm going to get rid of this scope and get a different one. See, it's so close. It's so close. And probably if I had a couple of hours tonight, I could go through and I could actually fix it. But I'm not going to do it now. Let's look at what does Jupiter look like. Let's knock it way down. Yeah. Yep, I don't think we're going to get a decent view of Jupiter right now at all. Not with this telescope, at least. Alright, well, let's do the alternative. Scope number 2. Okay, so the Ritchie Cretan is out. Not having any luck with it. Instead, we're going to switch over to the Teleview, which I always have gone for. So, Teleview. This is a apochromatic refractor. So, that means that it is a very nice scope, and it does not have color. So let's see if we can find Jupiter now with this one. Switch it to 40%. Yeah. I don't see a Jupiter. My exposure's my exposure's way too short. That looks like something. That looks like something. Well, let's figure out what it is. There we go. That's something. I see stars right away, or sorry, I see moons right away. So let's go ahead and, oops, I did not need that. Let's get down to 10%. Hold on, if this is what I think it is, I'm going to be annoyed. Do you see what I'm saying? Do you see that same type of pattern with the focus? You know what that tells me? It tells me it's not the scope. It tells me it's the filter. That tells me it's entirely possible it's the filter. So I'm going to do this. I'm going to... There we go. 1 second exposure. Let's see if we can knock these down. I'm going to do something interesting. I don't know if you've seen this before. Okay. I'm going to do this. I'm going to put a focusing mask, here we go, on one of the telescopes. What this lets me do is when it's out of focus or in focus, I get a specific pattern. That would be one of the airplanes from Sphinx. see this pattern. What this pattern tells me is I am not in focus. This is much better on a star or any other point source of light. It's not that great on Jupiter. Let's see what it's like when I blow it up on the moons. See, it's not quite what I want, but that's okay. We're going to do this. We're going to knock this way down. I kind of want to see what it's like on Jupiter. What I'm trying to do, oops, see, that's out of focus now. I'm trying to make this symmetrical. I'm trying to make it so that the pattern looks the same on both sides. See, that's slightly out as well. I've got to go back just a tad. So what I'm trying to do is make those spikes as symmetrical as possible. And it's not quite there. I have a little ways to go. So all I'm doing is touching the focus and watching the monitor. I gotta go back. There we go, that's a little better. Let's see what that's like. Not quite. This works pretty well on a star. Kind of hard on Jupiter. Look at that. Rotate this. See, let's move the rotation a little more. See, that's really, really close to what I want. Almost there. Very, very close. Touch it and see what happens. See, that is what I'm talking about for symmetry. That's what I want it to look like. At this point, this is probably in pretty good focus. So we can take off the mask. I think it's called a Blatanov mask. Okay, and what we're going to do now, so we've got Jupiter. This is a live view, and we have the moons. We want to make sure which moons they are. Let's do this. Let's go ahead and bring up Starry Night. So we got Starry Night. So I'm going to say, you know what? Let's do this. What do we have? Ganymede Europa. From outside, it's Callisto, Io, Ganymede Europa. So let's see what this looks like here. And zoom out a bit. Right. 50, let's go a little more. Let's do 100. Okay, so what are we looking at? 3, 4. That's a little hot pixel. 1, 2, 3. Oh no, wait. Let's knock this down. It's a 5-second exposure. There we go. Now we got something. So now we're doing just a 1/10 of a second. Somewhere about there. Now we can see all 4. So let's compare it to what we're looking at on Starry Night. So we're looking at Io, Callisto, Ganymede, Europa. So Ganymede is the one that's close in. So that means it's probably, I can't tell if it's in back or in front. So I'm going to guess Ganymede, Europa, Io, and Callisto. Callisto? Callisto. Yeah, that would be out. Now, Io's the one closest in, so this is way on the outswing on its orbit. And I don't know if you can see anything. I'm just going to swing you back here. Y'all can look at me. Okay, so kill the headlight for now. Okay, so let's go back to the view. So here's what we're seeing. We're looking at Jupiter and 4 moons. So right now you can see Jupiter's fairly overexposed. We have to overexpose it just so we can look at the moons. If I come in and try to knock it down so Jupiter is better visible, there we go, I get some banding there, then the moons disappear. There's not enough light to for the moons to show up and Jupiter at the same time. So we're going to go to, what, 300? Yeah. Oh, little moon popped in just barely in there. So what are we looking at? We can see some banding. We can see some bands. I don't think the great red spot is up. Let's double check. No, I don't see the great red spot. Where is... Oh, Star Sun says it's up there, but it's not. So here's what we're going to do. We're going to go back to here. I'm going to zoom out to 50%. No, less than that. Let's do 25%. So we're over here. And let's max it out, because I just want to see where the moons are again. Okay, so we're looking at Ganymede and over here. I don't know why it does that. Zoom out a little bit. So this is about the place where we should be looking. So let's go to what's the center array? No. No, 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 no. No, 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 no. Oh, you stupid. Well, that was dumb. Alright, tries again. Where are we? We're way over here. Okay. I'm going to swing it back over. Because for some reason, this thing's not the brightest. There we go. Alright, what I'm trying to do now is recenter this on Jupiter. So, we're just going to do this. We're going to minimize this just a tad. Because I want to see Jupiter appear in there. So I'm going to say... where could Jupiter be? I see no Jupiter. We're probably a ways away. Okay, let's do this manually. It's gotta be manual. So I'm going to step away for a second and refine Jupiter. Okay, well, at least I know one thing's working, so let's go ahead and recenter it. Because here's what I want. I want to see Jupiter pretty close to the middle. Yeah. So, with Jupiter in the middle there, I can actually come in and say center, and I should be able to say recenter. Where is it? Sync on Jupiter. Good. So now this is synced on Jupiter. Why it's moving off, I don't know. Looks like it's not tracking now. Oh no. You've got to be kidding me. Well, that's interesting. That was actually pretty bad right there. I'm not really certain what happened. I think it's the mount. No? Let's check out Story Night again. And where is... Hello? No, it's actually not going. This is not good. Not good at all. Okay. Okay, something seriously went bad. So, as far as I can tell, when I tried to do a sync on it, it actually stopped tracking completely and didn't let me go back to the east. Oh, and this is lovely. Okay. The telescope is all jacked up now. Funny. Real funny. Home position. Enter. Enter. Alright, this is messed up. Okay. Power reset. Oh boy. Oh boy. Okay, that's fine. Okay, we're going to try this again. Okay. Once more with feeling. So, what's going on is something that's not a whole lot of fun. So I'm having mount issues yet again. It's pretty frustrating. And what's going on is I lost my tracking control. I should be able to get this thing done. It didn't like it. So I'm having to reboot it. And when I reboot it, I can do this. So I call this the semi-auto magic. There's a small camera that's mounted on one of the telescopes. It's basically a small telescope with a CCD on it. And what it's doing right now is it's going all around the sky and it's taking photos. So it stops, takes a photo, stops, takes a photo, stops, takes a photo. And it goes all over the sky and it figures out from there where exactly it is, where all the stars are, and what its position is, and how far it has to move in X direction to look at whatever object it's going to look at. So, let's see what it's saying. There it goes. Here's next object. Or sorry, next section of the sky. So it comes back and it says, I found 99 stars in this section of the sky. And then it does what's called a plate solve. So it actually is comparing the stars in the picture that it took with the stars that it has in the database. And once it has a good image, it figures out, oh, I'm looking at this part of the sky. And then it goes on to the next section, and the next section, and the next section. It just keeps going until it's all done. So it should only require, at the very minimum, 3 images, but to get better resolution, it's usually something to the effect of, 5, 6, 7, something like that. And for this last image, it took 45 stars. Now it's trying to do another alignment, a close one to where it was, and seeing if it can't find whatever it's going to look at, whatever it's going to see. Okay, it's plate solving, solved, and that's it. So alignment is done. Alright, well, Jupiter's been fun, for a given value of fun. Let's see if we can find something else. So I gotta go back to telescope control. I have to reconnect, and we're not gonna make that same mistake again. Configure, okay, connect. Good, now we got it. Where are we? Decently. Or if it's going to do something stupid. So what's it doing? Is it playing stupid games? No, it's actually getting Saturn in the right way. Kind of. It'll be fine. Alright, let's see how close we got to Saturn. And we'll go ahead and bring it up to here. Telescope control, we don't need that. I don't see Saturn, which means we gotta figure out where Saturn is. And I'll head over. Headlight back on. What I'm doing is looking at a red dot scope to see where Saturn is. Bent down in interesting ways. It's not close enough. How close are we? Yay, we have Saturn. Okay. Saturn. So, there is Saturn. Let's see what what this says. I don't want to sync on Saturn. Let's look at Saturn first and see what it says, or what it looks like, and then we'll try to sync on it. So that's actually pretty close to the center. We'll go away 50. So there we go. And swing the camera back on me. Okay, how's that? Alright, so we're looking at Saturn, and we see a couple of stars in here as well. Could be moons. We'll go ahead and look at the map later. So just by blowing it up. Oh wow, here we go. So I'm just going to make a little bit longer. And here's what we got. So I'm taking a longer exposure. We'll go 250. So now we can see 1, 2, 3, 4, 5, 6 maybe. Let's zoom in on Saturn here and see what we can find. Because I want to, and we're going to center on Saturn so we don't miss it. Okay, so what are we looking at? Probably 1, 2, 3. One, two, three, Enceladus, Calypso, Mimas, right there, Tethys, Dione, Rhea. Where is Titan? Titan's down here, so let's say Titan's the big bright one. So where would Titan be? This would be Titan, because Titan's, well, maybe not. Hold on, let's take a look over here. Titan would be over here, and I don't see Titan over there. I don't see another. This may be it. That may be Titan right there. If that's Titan, ooh, it's so hard to tell. Let's go ahead. Just go back here and we can figure it out. The way we figure it out is we drop the exposure down. Oh yeah. There we go. So we can just barely make out the Cassini division right here and right here. That's what separates some of the rings. I'm going to zoom in even more. Let's go 400. Now, I'm not magnifying this a lot through the telescope because the telescope's not going to be great at it. But this isn't half bad for what we're seeing. We can actually see a little bit of banding right through the middle. And seeing right now isn't great. You can see kind of just flopping around. That's actually the air. That's the air in motion that's causing that. It's not the telescope. The telescope is keeping it pretty steady. It's just flopping around in the air. And it's because I have such a short exposure that we can see that. If I lengthen the exposure, you can see a little bit more flopping, not that much. If I do a half second, it's not flopping as much, but we do see the moons pop out. That looks like something over here as well. Let's blow it up a bit more, 2.2 seconds, see what brightens up out of it. It's hard to tell, there's a lot of, it's hard to tell, maybe something right there as well. We'd need a lot more signal processing, but we can definitely see something here, here, that's definitely Titan. And we have 3 moons over there. Let's knock this thing down, back down to here. So this is what we're looking at for Saturn. And through the scope, it's actually a little bit better. The problem is, of course, the camera itself. This is a 6 megapixel black and white camera. This is meant for exactly what it's doing right now. See if we can get a little bit better. Maybe this will work. stacking it well. That's fine. This isn't really meant for this type of work anyway. So let's turn off the live stack. We're just looking at it. What stacking does is lets me put multiple images, one on top of the other, like layers of an onion or layers in Photoshop, and it adds up the light pixels, and then it kind of cancels out all the noise, so you can pull out a whole lot more detail. And the typical way that astronomers do it now, well, amateur astronomers, is you take a camera like this and then you record Saturn for 2-3 minutes at a high frame rates, and then you run that through an application that'll go through and toss out any images that are bad. It'll just take, like, let's say best 5%, best 1% even, and then it stacks those. So for here we're just seeing a whole lot of air motion. See a little bit of detail. Again, we can see a little bit of banding across the middle. Excuse me. It is almost 11 p.m. and the Cassini division over here and over here. So what if I drop this down a bit more? Yeah. And what we can also see is, what we can see there is a little bit of the shadow, this dark part back here on top of Saturn. This is the shadow of Saturn being cast back on the rings. Yeah, that's definitely tightening. Alright. StarSense claims that it's over there. It's actually not. So we're going to fake it. What I want to do, because I know roughly how big it is. It's about that big or so. Let's see if I have a field of view calculator that I made for this or not. Field of view indicators. No, I guess I did not. No, I did not. I do not have a field of view calculator for this, but that's okay. 1 degree. I think it's bigger than 1 degree. I think about 2 degrees. So here's what we're going to do. We're going to take a look at the Lagoon Nebula. Let's see if this works. Wrong direction. I'm going to drop it here and we'll see. So this is kind of, I don't want to say a cheat, but we'll do this. So 50%, yeah, let's make it less, 40%, we can see the whole thing. Okay, I see nothing, absolutely nothing. We need a much longer exposure. In fact, I'll go to LX mode. Hey, we have a star. We got something. A couple more stars. Okay. Let's really crank up the exposure. I'm going to go for 4.3 seconds. I'll see what we can see out here. Ooh, a lot more stars. Okay. Let's keep pushing it. I'm going to go 9.3 seconds. I'm going to see what this does. There we go. Now we got some more stars coming in. At 9.3 seconds, that's not too bad. Let's go 20 seconds. 19.1. So what this is doing is it's basically keeping the shutter of the camera open for 19.1 seconds. When it does that, it adds up all the photons that each individual pixel and comes back with some results. So I've got a lot of stars here, but not really what I'm looking for. So I'm going to dump back to 36 seconds. What I'm doing is incrementally making it longer and longer so I can try to pull out some more detail. I want to see what this thing looks like, so let's see. Still going. You can't actually see what's going on here. I actually have a little counter, so I'll kind of show you what's going on here. Move this up out of the way. There's a little, yeah, how about that? So there's this little graph here, and that's showing me how far along the exposure has gotten. So that's actually not half bad, but it's not really what I'm looking for. I'm actually looking for the nebulosity. What I want, I think I'm seeing something like this. It's hard to tell, but that star, 4 Sagittarii, that's actually close to what I'm looking for, I think. Probably need some caffeine to stay awake. Okay, so I need a longer exposure. Let's cancel this one out, and let's go for 51. I'm going to go for a full, just call it 60 seconds, close enough, 58 seconds. So for the next minute, it's taking an exposure. And I don't know what it's going to be. We'll see. We're currently at mono 8, so I have the option mono 16 or mono 8. What that means is it's either 8-bit or 16-bit on the image. 8-bit is going to be faster to download, faster to process. I have a little bit of wind. Yeah, a little bit of wind coming from the south, so that may be messing up the camera a bit, but that's okay. Alright, we're almost there. 3, 2, 1. Okay, looking at the image, we see a little bit of streaking. That's not good. So the streaking is basically telling me that camera or the telescope is moving. So I want to see what I'm looking at. Because I want to know what it is. So I'm looking at the star right here. And what I want to make sure of is 1, 2, 3. Does it have 3 stars next to it? 1, 2, 3. Okay. I'm actually looking in the right location then. What I should be seeing here, I think we can see it. This haziness here, I think that's the actual the nebulosity. I want to see, yeah, this is a little bit better. There's less streaking. And let's zoom in. See, we're picking up a lot of faint stars. I think that's some of the nebulosity that we're seeing. So that's not too bad. This haziness, we don't see the haziness out here towards this edge. Now there's such a thing as vignetting, but this is a pretty small chip. I don't think we're seeing vignetting. This is actually the nebulosity that we can see. So what I can do is punch this up a little bit more. Let's go 120 something seconds. So this will be 2 minutes of exposure, and it's not going to look good because we have a little bit of wind, and I'm not doing any guiding right now. I just want to see what it looks like with a 2-minute exposure. So right now down here in South Fort Worth we have a lot of light pollution. I may do one down from a cousin's place in Grandview where it's quite a bit darker. We can actually do some deep space stuff. But we may do that now in just a little bit. So Jupiter's down, Mars is coming up. So we'll look at Mars in just a little bit. First I want to get this exposure done. So we have another minute left. Should probably have some red lights so it's easier to see. Oh, Doc, you're sticking around, huh?
So?
Okay. Dr. Ewan's still watching and asked if you're bored yet. Okay, we got 20 seconds left on the exposure. And let's see what it looks like. 13, 12, 11, 10. So this is actually what a lot of astronomy is. It's waiting. You start imaging and then you wait. Then you wait some more. Then you keep waiting. And then you wait. Then you wait again. Okay. You can see the streaking. All that gray, I think all this gray is actually part of the nebulosity. But because of the streaking, I'm not seeing any detail in it. I think 120 seconds is too long without any tracking. So, yeah. Alright, let's see if we can see something else interesting, because I don't think we're going to see much with the nebulosity. It kind of sucks, but it is what it is. So, I'm going to look for some other interesting objects. Here's M28. Ooh, Sagittarius cluster, M22. Alright, so here's what we're going to do. We're going to go here, and... Yep, wrong direction. Let's just call it right about there. So we can find Sagittarius cluster. Knock this thing down, 60 seconds, forget that. Dude, 10 seconds. Let's see what we can see with a 10-second exposure. That way it'll go fast, we'll know if we're in the right general area or not. So with this object, there we go. That's not bad. That's not bad at all. Globular cluster. That's not bad. So let's see if I go down. I want to center this thing out. Just make it easier to see. Nope, wrong direction. Well, let's see. We'll go slower. Yeah, let's go back here. There we go. Alright, so let's let it finish off. It's on Reddit. It's on Reddit. The link's on Reddit. You can see it there. Fort Worth. Okay. I'm going to zoom in a bit so now we can see again. So this is a globular cluster. And let's get some details on it. So this is called M22. So let's get a little bit of information on it, and I don't want to do sync, show info. So we're looking at description. M22 is a globular cluster, third brightest in the sky. That's quite nice. And M13, it's not bad. Okay, cool. So we're going to go position, and I want position in space. How far away? 10,000 light years. Okay. 10,000 light years away. So this is what we're looking at here. Yeah. Alright. So that's actually pretty decent. Okay. So globular cluster, this is actually independent of our galaxy. It's not really a part of our galaxy, it just orbits the galaxy. And sometimes it passes right through the galactic plane. So a globular cluster is basically a group of a couple 100,000 to even, I think probably a couple million stars for the larger ones. And they just form this big ball. They're all orbiting each other within this ball. It's kind of neat, and there we go. So this is with a 20-second exposure, 24, almost 25-second exposure. It's not bad. So what we're seeing right now, these are all individual stars. All the way down to the core, we're seeing stars. So this is probably maybe 100,000 stars in this whole area. So we can do, if I do 66%, yeah. So the extent of it's probably about that much or so, and some of these fainter ones may be a part of it as well. So what happens is that these come in, orbit around the center, and come out. Come in, orbit around the center, and come out. And all these stars are doing the same thing. They're all orbiting the center of gravity, which is in the middle. It's the average of where all the stars are. And the reason why it's so compact is because globular clusters will throw out the slower members, they'll throw out the faster members through, basically it's exactly the same as evaporation of a pot of boiling water. The hot molecules get thrown out and it cools down the temperature of the rest. So what's happening here is the fast ones get thrown out because they'll do a slingshot around another star, pick up speed, get thrown out. The other star loses energy and falls in closer to the core. So as the faster members of the cluster get ejected, the rest are proportionally slowed down, and when they do, the whole thing kind of compacts down and it stays fairly compact. So you can see it kind of jigged a little bit. We had a little bit of motion, either the mount or perhaps the wind. But I think that 24-second exposure is not bad. There we go. See, that's a little bit better. And if I want to extend it a little bit more, let's go ahead and let's just do a 37-second, 38-second. I just want to see what this looks like. If we get a little bit more detail out of it, if we have a little bit more wind, a little bit more jig, we'll just watch it and see. Bush? Okay. So coming up, 20 seconds left. Seconds. And like I said, this is really what astronomy is. It's boring. There's a lot of wait time, a lot of downtime. That's not half bad. So we're going to go mono 16. I just want to pull that one out, and I want to see if we can get a little bit better detail. Maybe we will. I like this exposure. We can actually see a lot more stars down in the core than we could before. My mother-in-law is now watching. Hi, Tishjova. So, looking in, we got another 8 seconds, 7, 6, 5. Let's see what it looks like if we get a little bit more detail out of it. That's actually a little bit more detail. We can see that the black's got a little bit blacker, and this came out. So that's 66%. I want to zoom in 200. So we see a little bit of elongation in this direction. It's very, very slight, but it just means that either the telescope isn't perfectly aligned, which is, yeah, obvious, or we have a little bit of motion from wind. But we do see a lot of stars here. Each one of these dots is going to be part of the cluster, and we're resolving pretty close down to the core. This is actually pretty decent. So there are a lot more stars than we can actually see. They're actually very, very faint, but they're still part of the cluster. And there should be like a couple 100,000 stars in this cluster. So we're looking at M22 on here, Sagittarius cluster. So this whole thing here where we're looking, this is the Milky Way. Oh, we got Ptolemy's cluster. That's not bad then. Ptolemy's cluster is a little bit lower in the sky. We have Butterfly cluster. What do we have up high? Something interesting. Here's Sagittarius. Here's Omega. Here's the Eagle Nebula. Here's a Wild Duck cluster. That's always interesting. Altair. The Dumbbell Nebula. The Dumbbell's actually a pretty good thing to see, if only we can see it better. Let's see if we can pick out some galaxies, but these are just more globulars. M72, yeah. So, I want to see if we can find a decent galaxy. M2, this is nebula. No, it's another cluster. This is another globular, so we'll M15 Andromeda Galaxy in the northeast, in the Clag. That's not going to be fun to see. M39 Denab. Okay, what are we looking at? M39. 39. This is a pretty open cluster. This is the North American Nebula. So it's called North American Nebula because it kind of looks like North America from the side. You have Gulf of Mexico, Mexico, Central America, Florida, and then everything else. And the Pelican Nebula is actually right over here, right next to it. It's just not showing up here. So I think we've got the Ring Nebula. Okay, we're gonna be able to see some stuff. So let's go back. So we had a little bit more motion. 13 more seconds. Yeah, a little bit more motion to it, but not horrible. I can't hear you. What? Yeah? It's almost a live picture. I know. What? Yes, dear. Yeah, this is, yeah, we're getting a little bit of motion, so that's why it's not looking that great. But yeah, this is live. Okay, next, let's find something else. I'm gonna knock this thing down. 1 second exposure. See, with the 1 second exposure, you can barely see anything. Even with a 2.8 second exposure, barely anything. Only the brightest of the stars. You really, really need to let it sit there with an open aperture, or sorry, open shutter, and just keep gathering photons to get decent images. So I think let's do 10 seconds. 7.7. Let's leave it at 7.7 because now we got to hunt other stuff. Let's see how long. Yeah. So now we're going to be able to see something. All right. So what's close by? Mega Nebula, Wild Duck Cluster. Let's do. Here's Mars. Mars has been kind of featureless. Yesterday when we looked at it, it was red, and that was really about it. We couldn't really make out any surface details on it. There was like a little bit of a darker area. We could not make out the poles at all. What's going on right now is that Mars has a major dust storm, so the surface is pretty much just washed out. It's not good to see here, but Pluto's going to be very, very difficult to see, so I'm not even going to bother. But let's look at M52. Let's see what else is out here. This is an open cluster. It just means a group of stars. And we have, what's this? The Sagittarius. Well, let's look at M25. Let's see if we can. Let's see what M25 looks like in here. Complete the exposure. All right, one more exposure. I think that's it up there. Oops. 15 seconds. So we're looking into the Milky Way right now. I wish this thing was aligned better, but it is what it is. Yeah, so this is just another little open cluster. Nothing terribly special. Do 30 seconds, and yeah. What are we looking at? Yep, M25. Open cluster right here. That's what we're looking at. When we look at this. So this is the whole open cluster. Basically, it's just a group of stars that formed together, and now they've moved out of their birth nebula, and now they're just in open space. So they're just going through the galaxy, and they're actually spreading out. Most open clusters, they've gotten rid of their primordial gas and dust. They're out in the open, and they're now spreading out. So our sun was actually part of a cluster as well. And after 4.5 billion years and a couple times around the galaxy, I don't think there's any way to find out. At least not yet. Maybe sometime in the future. So we're going through one more exposure. Alright, so now we're looking at M25. Yeah, M25. So now let's look at this. This is the Sagittarius. This is the Sagittarius star cloud. Let's see just what we can find. So it was streaked out, and let's just let it start again. Maybe it's not streaked out. It moved too fast for it to do that. But we'll wait another 18 seconds. Let's get an image of this. So the Sagittarius star cloud. The center of our galaxy is in Sagittarius. So when we're looking towards that teapot, we're looking at the center of the galaxy. And the Sagittarius star cloud is, I believe it's a remnant of another galaxy that was cannibalized by the Milky Way. And we can see a lot of stars there, but it's such a big area that it's hard to really see much. And I'm going to just do a minute-long exposure in 90 seconds, 80 seconds. Let's leave it at that. Let's see what we can find. So, because it's so far away, we really need either long exposures or larger telescopes to really see it well. And pretty much all astronomy now is done with cameras. You don't really find any scientific astronomy done visually anymore because our eyes aren't that good. So most of what's done is actually now with very sensitive cameras. Uh-oh. What happened? No, it's still going. Okay, good. I thought it stopped. Right, sorry. It's done with very sensitive cameras, cameras that are cooled. So what that means is there's it's called a Peltier cooler. It's a thermoelectric, a solid state device, which when you run a current through it, one side of it gets very hot, one side of it gets very cold. So you find these devices on portable refrigerators that you'll find like in a car. It's like a little bitty mini fridge. There'll be like a fan on the back. A lot of wine chillers, wine refrigerators now use the same technology. There we go. So in order to get better images, what happens is we put the thermoelectric cooler directly onto the back of the imaging chip, and then we put a big old heat sink and a fan on the hot side. So when you run the current through it, the cold side gets very, very cold. It can get down 40 degrees below ambient Celsius, and then the hot side will be very, very hot. So you have to have the heat sink. You have to have the fan to blow away the heat, to cool down the heat sink, because otherwise that cooler will overheat and it can crack and break. Now, the reason why we do this with astronomical cameras is because the cooler you get the chip, the less noise there's going to be. So you'll have basically a darker black than you would otherwise for the black of space. And you want to get that chip as cold as possible without dew forming on it. So there's a lot of techniques with, you have a window in front of your chip, and the chip and the board behind it is sealed from the atmosphere, so water can't get there. But this little window in front of the chip is now, you can have a little heater on there to prevent any dew from forming, so the chip is still very cold, but the window stays a little bit warmer than your dew point. Yeah, you can see right now it's not tracking very well. We got a little bit of streaking on there. So these cameras don't have a cooler. I do have cameras that do. So it's basically, the way you would see from the outside is there's a big old fan on it, and that fan is sucking in ambient air, cooling down the heat sink, and blowing out hot air. So we're still getting an image. Okay, so let's see what this one image looks like. Then we'll go on to a different target. So again, this is the Sagittarius star cloud. And we just need a couple more seconds. So 20 more seconds. Let's see if we can get at least one image without it streaking. And so remember, we're looking deep into the Milky Way right now. What I mean by deep into the Milky Way, in this case, in Sagittarius, is we're looking towards the center of the galaxy. So looking through as much, pretty much as much stars, dust, gas, and other material as we can, as long as we're within our galaxy. Okay, so we're getting some streaking. That's fine. You can at least make out some of what's in the Sagittarius star cloud up here. Alright, we're going to leave it at that, and let's go to something else. So, Sagittarius star cloud. Let's go up here. I want to look at the Omega and the Black Swan. Oh yeah, we're getting some wind. I just want to see what this is going to look like for the Omega Nebula. This is going to be... I'm going to knock this down to here. I see nothing. Wow. There was a buzzing sound, and I'm looking around. I see a drone. Someone's flying a drone over the neighborhood. It's red with a flashing green light. Quite interesting. So right here he's going to come over here. Okay, well, we got the Black Swan down here. That's actually quite neat. Okay, so we're looking at the Black Swan. And we can verify that. Coming in. Is that, well, maybe not. That actually could be Omega. Black Swan's actually a bit smaller. That, we're probably looking at the Omega right now. M17. Yeah, we're looking at the Omega. Let's see, 1, 2, 3. I want to see those 3 stars, and I got 3 more stars over here. 1, 2, 3, and 3 more. Is that the way we're looking? Well, 1, 2, 3, 1, 2, 3. I don't know, it's hard to tell. There's a couple more over here. It's hard to tell from the orientation, but I think this is right. I got the camera aligned right. So I'm going to make 20-second exposure. Let's let it finish, and then we'll bump it up a little bit. Yeah. Let's go 33 seconds. So the Black Swan cluster. So this is, or sorry, the Omega Nebula. We're going to Omega for now. So this is yet another star-forming region. Take a quick look at what it is. So, let's see, where is it? Show info. Cluster with nebulosity, and here we go. Looks kind of like the Omega. Alright, yeah, clear and dark skies. It can just barely be seen with the naked eye. Yeah, we're in the city. We ain't got nothing. So it's 5,000 light years away that you're looking at these stars. These over here. And our friendly neighborhood drone is almost directly overhead. It's not circling, he's kind of just flying around. That's kind of interesting. He's circling back. I don't think he can do that because we're very close to an airport. I'm just going to wave to the drone for a bit. Oh, he's coming for landing at the neighbor's place. Or he's just watching me. You know, 15, 20 years ago, if anyone had seen a drone flying by like this with just red light and a bit of a buzzing sound, it looks like a UFO. Absolutely looks like a little bit of UFO. Well, a UFO. It's hard to tell how big it is, but I think he's coming. I don't know if he's coming in for landing or not, but he's a lot lower in the sky than he was. And now he's coming back up again. It's just kind of interesting. I haven't seen anyone fly drones around here, especially at night. Alright, so we should be seeing some nebulosity, but at 33 seconds, that's not a long exposure. I'm going to go ahead and shoot off for, let's just do 100 seconds, 102. So with this, if there's any nebulosity that we can pick out, we should be able to see at least a little bit. This is probably going to be better than what we saw previously in the Lagoon Nebula because it's going to be much, much smaller, more compact. It's kind of what we want to see. Oh, Mr. Drone, he's heading directly overhead. Yeah. I don't know if he really knows what I'm doing, but yeah, he's overhead. He's watching. Alright. We got a minute left. That's fine. It is weird, though. It's quite weird because you just see this light, and he's got a red light and a flashing green light, but the green lights aren't always on. And sometimes it's a very bright red light, and sometimes it's just two other red lights. So I don't know what that red light means. I'm pretty sure it doesn't mean he's backing up. But that's interesting. I'm wondering what his range is. Alright, so we got another 23 seconds, okay. I think he's gone now. At least he's far enough away that I can't hear him. Alright, one more second. Let's see what this looks like. Okay, I still don't see very much nebulosity, if any at all. I don't think a 2-minute exposure is really enough. One, there's a lot of light pollution. If we're in a dark sky, so let's try to find something where we can actually make out some nebulosity. Alright, so we have the Eagle Nebula. Let's look at the Eagle. Alright, that should give us something. So I'm going to knock this thing down again. Let's just cancel it. Yeah, give it a couple seconds. So, the Eagle Nebula. back in the 90s and again in the early 2000s, Hubble took the very, very famous picture of the Eagle Nebula. It's the Pillars of Creation. So, Pillars of Creation, let's see if I can find it. Yeah. Images. Okay. So, wait for this to come up. There we go. So these are the Pillars of Creation. This is the center part of the Eagle Nebula. And I'm not seeing a thing. I don't think we can actually see the nebulosity of it here. In Starry Night, let's bring that up. So if I zoom in on it, this is the central part we're talking about, right there. It looks like it's called Eagle Nebula because it looks like an eagle. Here's the head, here's a claw, another claw, tail back here, and it's got these huge wings that come way out. So there's that. We have this. So we have the head here and claws, and the wings go way out. This is the very famous Hubble image back from the 90s. Actually, no, this is the one from early 2000s, I think, is when this one was taken. It's not the one from the middle 90s, I think, or early 90s. So, oh, Mr. Drone is back. All right, let's ignore him. And what I'm going to do is I'm going to bring up. Let's see. I'm going to bring up my Imgur account. Sign in. Alright, so we're looking at that. Let's see if we got any further with that. Not really. We're just not seeing very much nebulosity. So, albums. I'm going to hit my albums. There you go. I'm just going to hit images. So, non-album images. Okay. Alright. So, here's some images that I've taken. Here's the Eagle Nebula. Yeah. So here's the central part of the eagle, right there. And if we look at it here, I can't even, wait, here we go. Right there, maybe. Maybe. We got a bunch of stars up above. I can't even tell. I can't even tell. It's just too hard to see. And we got too much streaking going on too. That doesn't help it any. So Eagle Nebula is going to be somewhere in here. Let's go back to my image. So this actually took a little while ago, 2 years ago, on a robotic telescope. This was a Takahashi 6-inch Apo refractor with a very, very nice camera. So there's about 60 minutes exposure for everything. And this was done in just one-shot color camera. So I also used a different camera to take an image in just hydrogen alpha light. So you can see here's the head, here's the claws, and let me see if I can just do this. So I'm just going to open it up this way. It might be easier to see. Yeah, here we go. Oh yeah, that's much better. So you can see here there's a lot of detail, and this was taken with a monochrome camera, using a special filter that only lets in one very narrow bandwidth of red light. It's called hydrogen alpha light. So what you're seeing, all of the gray stuff here, what it is, it's hydrogen gas that's being excited by ultraviolet radiation from hot young stars all in here. This is some dust that's blocking the light. Same thing with this and this here. All the dark patches are basically dust. The light patches, that's all hydrogen gas that's being just excited. Now you can see the top of the head here, and if I come in this again, the top of the head here, that's all being lit up. So the ultraviolet light from these stars is basically causing the gas here to kind of boil away. It's giving it a ton of energy, so it's glowing. And by giving it that energy, it's also causing it to move out. So it's basically evaporating these things. And because they're so far away, astronomers tend to think that this no longer exists the way it does. That the ultraviolet light from these hot young stars has already destroyed the petal's creation. So what we're seeing is several thousand years in the past. We're not seeing it the way it is anymore. So, thanks to relativity and speed of light limitations, we're looking at the past. So, yeah, we can't really see it now. Get this out of the way. But this is pretty much what we're looking at for the Eagle Nebula. Again, I need longer exposures, I need tracking, and I need less wind. We can hear the wind, and yeah, it's not an ideal night. Okay, Eagle Nebula, let's keep going up. Wild Duck Cluster, I don't want to do the Wild Duck Cluster, I want something more interesting. So, Mars is getting up there, but it's not that interesting, really. I suppose we could do it. Let's just do Mars. So over in that direction. See how close we are with a much that could be Mars. Let's see. Oh, yeah, it's Mars. Actually, I'm pretty sure it's not Mars. Mars is going to be much bigger, much brighter. Yeah, that's definitely not Mars. That's Mars. Oh, 10 seconds, yeah, that would do it. Really? Come on. Now we have Mars. Let's zoom in on it. There's Mars. Remember, this is black and white, so we're not going to see any red. These are not the moons of Mars. We can't actually see them. They are way too faint. And a half-second exposure is too much. Wow, we really have to go down. Alright, let's zoom in a little bit more. A lot more. Yep. We really can't see much detail on it. Even going down. That is probably the ice cap, but it's just so hard to see. We're just not seeing any detail. It looks like it's out of focus, but it really isn't. There's just the dust cloud on it. We're just not seeing it. So if I go here, let's see. I'm going to find Mars. Yeah. So here's what Mars is looking at right now. This is what it normally looks like. This is what we're seeing right now through telescopes. Because there's a global dust storm, it just obscures all the surface features. And this is typical weather on Mars during the Martian summer in its northern hemisphere. I think it's northern hemisphere. Or it could be the global summer. So when it gets warm, which is warm for a given value of warm for Mars, it heats up the atmosphere. The atmosphere moves a lot more, and when it does, it picks up dust. So you have high winds, pick up a lot of dust, take it high up into the atmosphere, and just obscure the surface features. So we're not seeing much. We really can't. When we were looking yesterday, a friend of mine from the astronomy club came over with his 12-inch, and we were looking at Mars, and it was just a featureless red hazy ball. We were not making out enough detail to say anything. So we could see like one little darker area off to the side, but that was literally it. So again, let's go back to Mars. It looks like there's a darker area right here. A little bit of a lighter area that pops up every once in a while. So this would be probably the southern pole. Here's the northern pole. And that's about it. When we were looking at yesterday, the darker patch was in this area here. It was kind of, I mean, it was there, but there was nothing interesting about it. It was just a washed out red ball. And we kind of see the same thing today. It's washed out. There aren't any details on it. Can't really see much. Alright, let's find something that's at least a little bit more interesting. So the software I'm using here is Starry Night Pro Plus, I forget, it's one of those, Pro Plus. So what it's doing is it lets me control the telescope and look around and view all sorts of stuff. So I could swing it to the northeast, look at Andromeda, but I don't think we're going to see much out of that too. Instead, let's flip it up. I want to look at Pegasus M15. That may be interesting. Yeah. drone is back. He's kind of flying low right now, but that's okay. If you're asking about Neptune or you're thinking about Neptune, Neptune's kind of hard to see. You have to know exactly where it is. We can take a look at it as soon as we look at this one. Alright, let's zoom in on this. Let's see what we can find. So, go back down to 40%, and we're going to have to go a lot longer exposure, so let's give it 2 seconds. 2.7. Hello? Something's not quite right, is it? Okay. Something just happened. Look at cameras. No, camera's on there. No, I don't want to reboot my computer. Pick up the camera again. So... I'm not saying anything. Alright, fine. LX mode. There we go. I don't see anything here. 5 seconds. Okay, I'm looking for 3 stars. Really? Alright, once more. There we go. Right there. Cool, let's bump that up to, give me 17 seconds. And percent down here and over. There we go, right here. It's small, it's compact, it's far away. There we go. That's pretty. Not as pretty as the other one. Is M22, was it? Yeah. That was actually really nice, but that one was bigger. So let's see, what are we at? 200? Let's go 200. Yeah, so this is another globular cluster. This one's probably further away. And it's, yeah, our wind is annoying again. So I'm going to bump this up to, let's go 30 seconds. So, this is another globular. And this one's in, was it Pegasus? Yeah, this is Pegasus M15. So, same thing as before. It is a compact ball of stars, and it's throwing out the fastest members, and the slower members just congregate down into a single ball. So, it's pretty. So, once it comes up, here we go, 2 more seconds, 1, 0. There we go. So, that's a pretty little compact cluster, and it's far enough away, and it's tight enough that we really can't resolve, at least with my telescope, we can't resolve down to the core. We see just this blob down to the core. I suppose if I had a bigger telescope and I was actually doing auto guiding, then that would work. But I don't have the camera set up for auto guiding, and I don't feel like messing with it right now. But we are doing that. Oh, see, let me check the live stack. I'm just curious if it'll stay. So what this is supposed to do with the live stacking is that it will take the image that I've just taken and add it to the next image, and the next image, and the next image. And I don't think you can do it. No, can't do it. Oh, that's nice. Our friendly neighborhood drone is directly overhead. I don't know how well you can see that or hear that buzzing. Yeah. So he's watching. That's interesting. He's hovering quite nicely right now. So, okay. Oh, we moved off a bit. Yeah. 200%. Here we go. So this is M15. Yeah, M15. So again, we can see a lot of these individual stars. He is going far. He's now back over my street. My kingdom for a Herf gun, right? Okay. So where were we? M22. No, M15, sorry. And we got some wind. Alright, M15. Let's look at something else that's more interesting than that. Dumbbell nebula. You know what? Let's just do the dumbbell. So the dumbbell, we may actually get some nebulosity out of it. Maybe. Yep. Friend of the neighborhood drone is back. It's a fairly quiet one, too. I think he's landing at the neighbors. Let's get in there, yeah. So I'm trying to stay relatively quiet. So here's a dumbbell. And the dumbbell is a planetary nebula. So I'm going to zoom out 40% so you can see it. Don't see it. I don't see it. Let's give it a minute. One more exposure, see what happens. So the dumbbell is a planetary nebula. Planetary nebula is what happens when a star like our sun dies. So at the end of our star's lifetime, it will turn into a red giant, and the red giant will then blow off its outer layers. When it does that, what happens is all that gas gets pushed out, and it gets pushed out far away from the star. and what's left is a white dwarf down in the core, and the core of our sun basically will be that white dwarf, and there's no more fusion going on. So um, all that gas is being heated up by the residual radiation from that star. It's very, very small. It's very, very hot. It's putting out a lot of UV radiation, and it's basically lighting up all those gases. So let's go back and describe it a little bit better. You know what? Let me see if I can get a longer exposure. I hope I'm looking in the right area. I think I am. With a telescope, naked eye becomes very, very obvious. With the camera, it's not. You kind of have to hunt for it. So, okay, let's describe what happens to the sun. At the end of its life, the sun can no longer burn off hydrogen gas. Yep, it's our drone. So I think he's landing, switching out batteries, and going for another fly around. So if he comes down, I'm going to throw one of my spare USB cables up there. Okay, so the sun, at the end of its lifetime, it will burn through all the hydrogen gas it has in the core. Once it doesn't have any more hydrogen gas, fusion stops. There's still hydrogen gas out in the photosphere, out in the outer layers of the sun, but there's no more in the core. So when there's no more hydrogen, fusion stops. When that happens, there's now nothing that's pushing out against the outer layers of the sun, basically pushing out against gravity. So the sun is, well, actually any object in space is basically a balance between the force of gravity wanting it to collapse down into a tiny little black hole and whatever energy is there pushing it apart. So in the case of the Earth, it's actually the repulsive forces between atoms that prevents the Earth from turning into a black hole. For the sun, what it actually is that it's the energy from fusion in the core. It's trying to blow the sun apart, but it weighs so much that gravity keeps pulling it back in, and so it gets to an equilibrium. Well, if all of a sudden the hydrogen gas, all of a sudden if there's no more hydrogen gas in the core, then it's no longer able to fuse. There's no more energy being created from that fusion, and so it begins to collapse. As it collapses, the temperature inside the core goes up, and the pressure goes up. Is that Boyle's law? So when that happens, now the helium, which used to be basically leftovers, we call it actually helium ash from the fusion reaction. The leftover helium then begins to fuse. So it's collapsing, temperature goes up, pressure goes up, helium begins to fuse, and then energy is created. When that happens, the sun blows up, but it blows larger. So that additional release of energy causes the outer layers to basically expand out. So the sun goes from a middle-aged star, as it is right now, to a red dwarf. And those very, very outermost layers become pretty tenuous. They'll actually be less dense than our atmosphere on Earth. It'll be very hot, but a lot less dense. So what we have is the outer layers get blown off. The sun gets much, much, much larger, and then helium stops fusing. And helium's been fusing into, I think it's lithium. So once the helium fusion stops, you have another collapse. And so it goes right back down, and kind of annoying. So it goes right back down, and when it does, now lithium starts to fuse. Generation of energy, another poof, and more outer layers get blown off. So every one of these pulses, as they're called, more and more gas gets blown off. Well, this is what happens in a planetary nebula. It is the leftover remnant of a star. Its outer layers pushed out far, far away from where that star used to be. At the very core, there's just a white dwarf left. It's the core of that old star. There's no more fusion going on. There's nothing. This is actually, I think it's called degenerate matter because of the pressure that was under. Um, at least for our star, it would be degenerate matter. If it's any bigger, then you can have neutron stars where the core is so dense that electrons actually fall into protons and they become neutrons. And then you have black holes after that. So let's go back to the white dwarf. So white dwarf is just the hot leftover core